All right, hello chat. Today I'm going to be talking to you guys a little bit about Encrypted Client Hello, ECH, and how it helps increase your privacy on the internet. A very quick, summary first so that you guys can get a quick overview. On the right, I have Wireshark open. You can kind of think of it as a program that logs all of the internet traffic going out in and out of your computer, and it, it's it's not 100% true, but you can kind of think of it as everything your ISP or the internet service provider can see, uh, or anyone in between you and the website. So this includes your internet service provider, the government, if you live in a country where the internet is monitored heavily, or something like that. And a very quick example of what the SNI is. So here, this is just a regular Edge browser, latest. The only thing I've done is I have disabled Quick or HTTP3 just because the packets are a bit messy in Wireshark. So I'm going to open up website example.com. And so this is everything your ISP can see. Well, I've kind of filtered it right now for only the TLS handshake. But basically, here you see the client hello. This is when your browser is establishing the encrypted connection, and it will leak the name of the website as the SNI, which is called the server name indication. So if I open, let me try to make the font a bit bigger. If I open up the handshake client hello, you can see there's an extension here called server name, and that includes the server name as example.com here. So your ISP or the government, anyone can see this, and then they can block the website. What Encrypted Client Hello does is it will hide the true website you're connecting to behind kind of a fake name or like a proxy name you can think of. So as an example, I will go to my own website and ignore like a lot of the Bing.com and all that stuff. I'm using Windows 11, so there's a lot of telemetry and shit like that. Um, but I'm going to open up my own personal website now, which is behind Cloudflare. And Cloudflare recently deployed Encrypted Client Hello for all their personal websites. So when I open this, you will see there's a client hello for cloudflare-ech.com. ECH here being Encrypted Client Hello. And basically for any website hosted behind Cloudflare now, if you use one of the latest browsers, either Edge, Chrome, or Firefox, I don't know about Safari, then it will use ECH by default, which means it will establish the first connection, the client hello outer to Cloudflare. And here you can see the client hello, the name as, let's see, server name cloudflare-ech.com. And what that does is it does an initial handshake with the Cloudflare proxy server, you could call it. And once that's established and verified, it will then do only to Cloudflare, it'll be visible, the actual website I'm connecting to, which in this case is saxrag.com. So then Cloudflare can serve the correct website and do the correct underlying handshake. And that's at a very high level. So why this is useful is because since the right-hand side is everything your ISP can see, they can use this to block websites. I've talked about it a little bit in a prior video about how ISPs block websites with DPI. And I also had a video about how you can use ESNI to kind of avoid that. ESNI was the precursor to ECH, which focused on encrypting only the SNI, the server name indication, this thing. But now ECH encrypts more of the handshake. A few other things. Honestly, for privacy, the only thing that really matters is SNI. And that's kind of it at a very high level. So how does this work? Again, I have some other videos on how ISPs block websites. But the main thing is when you connect to a website over TLS, right? So let's take this guy. If I follow the whole TCP stream, you can see this is everything that the ISP can see. So actually all the actual content, like all this text here, is encrypted by HTTPS or TLS. And that means that they can't see the actual content of the website. But again, if you were to go to a non TLS website, so let me go back to the old filter for example.com. So here again, it's all encrypted. The actual content was encrypted. However, the name of the website was revealed in the SNI extension of TLS. And there's a draft paper about it as well. It's currently an internet draft. I'll put a link to this in the description. TLS Encrypted Client Hello. And it talks about how it is offered, amongst other things. So basically, you will now have a website which offers what's called as a ECH config. And this config talks about gives you a public key that's published in the DNS record and a public name which you should use. So in the Cloudflare case, the public name is, let's go back to the handshake, is cloudflare-ech.com. And the public key, again, in the DNS record is how that will be encrypted, or how the initial connection to this will be established. And I can also show you what the record actually looks like. So there's a online DNS resolver, DNS resolver online HTTPS record. I think it's this one. Yeah. It was one for HTTPS or something. Okay, let's just go to the main website and I'll type my own domain name, find DNS records, and we're going to look for the HTTPS record. If it will let me look up for that one explicitly. Here. Okay, so other records, HTTPS. I guess I can't do that. Let's look up the IO. Yeah, here, okay. Hidden behind a few different things, but you can find the HTTPS record, and this DNS record, ECH, blah, 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 blah. This contains my ECH config, which includes the public name to be used for doing the initial connection, which in this case is cloudflare-ech.com. Let me just clear this out because there's so much noise from all the Windows telemetry. All right. Let me also show you guys an example of another website that I host, which actually publishes several different records. That is called rfc5746.mywaifu.best. And here you actually see, so this is the IP address of the website. 152, this is my server. But you see the SNI is actually example.com. Now the way I did this is because I actually publish for this website is not behind Cloudflare. So I can publish any kind of DNS record I want for ECH. And I publish several records for different ports. So when you connect on port 443, which is the default, the browser thinks the public name is sniexample.com. It'll establish a connection to the first TLS server with this SNI, and then the actual underlying connection happens to this domain. And here I have a little box you can also see if the ECH worked, the outer SNI, so this is what the ISP sees, and what the target server sees. And if I go to different ports, let's say I go to port 4443, it should be, it didn't work, so I actually used the public name. So I think I'm on Edge right now, and it looks like Edge might not actually correctly look up the ECH config for other ports. Let's try Tor project. Also no. Okay. Let's try this in a different browser now, such as in Chrome. So you can see HTTPS port 4443. And there you go, snicaa.gov. So Chrome correctly resolves even on non-standard ports. And you can see ECH success, outer SNI this. Let's try a few other ports. So port 3443, it should be at the piratebay.org. Didn't work. Okay, my guess is maybe if you just click on the hyperlink, it doesn't work. Let's copy and paste it in instead. No. So this could be a browser bug as well, as to how it works when you, if you've already loaded that website, then you go to a different port. Let me try this non-standard port. Actually, Firefox, I'm pretty sure it's broken. Let's put that in anyway. Oh, so Firefox, even on the non-standard port 6443, which should have been pornhub.com, it used the SNI of example.com, which is the default port. Which is, again, slightly incorrect behavior. And in fact, I actually talk about it here, that it uses the default ECH config for all ports. And there's a bug about it in Mozilla's bug tracker. But you can kind of use this website, which I'll link in the description, to test if your browser is using ECH correctly. And if it is, then at least all websites behind Cloudflare should be protected by default. So let's open up some other website behind Cloudflare. Let me try my personal website again, this time in Firefox. And yeah, you can see here, Client Hello all to cloudflare-ech.com. The real domain is not leaked. And let's open a website now that's not behind Cloudflare and probably doesn't have ECH on it. What do we have? I guess I don't want to open Reddit because there might be a lot of stuff on the Reddit homepage, which is not great. Let me try google.com. There you go. So Google doesn't have SNI on it, so you can see anyone in the middle can see exactly which website you're connecting to. They can't see the content, only the name of the website. All right, let's try Chrome again. So again, my personal website. Let me clear this guy out again. Behind Cloudflare. Should be protected, yeah. Cloudflare-ech.com. But if I open up something like example.com, you can see it is leaked. And then anyone knows who you're connecting to and they can try and block it. So ECH is a step in the right direction to try and make the internet more private by hiding the domain of the website you're connecting to. Of course, there's other ways for the domain to leak. For instance, if your DNS is configured to be just a plain text DNS or something like that. But again, by default, browsers these days use DNS over HTTPS. So those records are also hidden. And yeah, I think if you use if you use one of the latest browsers, you're on this by default. What you can do if you own a website is try and migrate your hosting to a TLS server that supports ECH. It's not that widespread yet, but there is a great project on Nginx forked by this guy. I think it's SFTCD or STFCD or... let me go back to my website where I have a link to it. Yeah. So this person's GitHub, they're quite prominent in the ECH kind of trying to promote it more and more. And they have a forked version of OpenSSL and also Nginx, if I'm not mistaken. Yeah. There's also some other servers like LightHTTPD and stuff, but I was able to make it work with Nginx. And using the forked OpenSSL and forked OpenNginx, you can try and deploy a TLS server that supports ECH like I have done here. And I did a very brief overview of how I did it. You can try and follow this. It's not the best, but it kind of tells you how to set up, generate your ECH keys and set up the DNS config and all of that stuff. Or you could just put your website behind Cloudflare. You kind of get it for free by default. But in that case, you can't control the actual SNI. Any website behind Cloudflare will have the SNI as cloudflare-ech.com. But if you were to do it personally, then you can choose kind of any public name you want. So actually, let me quickly go over that part. So I talk about it slightly in my notes, but basically when you generate the ECH keys, you specify the public name. This does not need to be a domain name you own. This could be any kind of domain name. So in this case, like on my website, I've used several ones like example.com, cia.gov, torproject.org, and this is only what the ISP will see, and this is only what you will establish the initial connection to, which just hides the inner client hello that contains the real domain name. So yeah, that's kind of how ECH works. If you remember the previous video I had about how to set up ESNI, there's a lot of work. You have to toggle some flags in your browser and stuff. But thankfully for ECH, it's out by default in the latest browsers. Let me check which version I'm on. I guess Edge flags. 129 on Edge. On Chrome and Firefox is also like 129 or 130, something like that. Hopefully you guys learned something new about how the SNI can leak websites in certain cases and how you can protect it now with ECH. All right, cheers.